Okay, so now we're going to do question number 27. Every year, Educational Services selects readers for the advanced placement exams. Recently, the AP Statistics exam has been graded in Lincoln, Nebraska. One objective of ETS is achieve equity in grading by inviting teachers to be readers from all parts of the nation. However, budgets are a consideration, and so the accountants of ETS wonder if the flights from cities west of Lincoln are the same as flight costs from cities east of Lincoln. A random sample of the expense vouchers from last year was reviewed for the cost of airline tickets. Costs are shown in dollars. Okay, so this is sort of the setup, and here's the data. So obviously, right, we have mean scores, mean prices, okay? And so this means that we're in a T model that we want to test, not a normal model or using z-scores, right? And so what we want to do is indicate what inference procedure you would use to see if there's a significant difference in the cost of airline flights between east and west, west and east coast to Lincoln, Nebraska, and then decide if it's actually okay to perform that inference procedure. Now I told you we're going to use the T model, right? Okay. Now, usually says, right, check the appropriate assumptions and conditions and indicate whether you could proceed or not. Here's the key. You do not have to do the actual test. If we had to do the actual test, if one of the assumptions was a little sketchy, we would still do the test and then mark that, okay? But here it's actually asking us to check all four of the assumptions. Independence, right? Randomness, the sample is less than 10% of the population, and the nearly normal condition, right? Here, if any of these four conditions are not met, then we have to say that we cannot proceed, okay? Could not proceed. If they are met, then you just say you can proceed, but we don't actually have to finish the test. We just said we could use it, okay? Now, if you're thinking about flights, east and west and stuff like that, those are going to be independent. It doesn't seem like flights from the east are going to be dependent on flights from the west and flights from the west and vice versa, right? So independence is probably a pretty easily met condition. It does say that they did, where's the inviting readers, however budget considers, a random sample. Okay, so they collected a random sample, so randomness is met. Okay, now I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so here my sample size n is equal to 10. And so that basically means that the population has to be at least 100. All right, now these are the AP statistics exams. There's lots and lots and lots of those, which means they need lots and lots and lots of graders. And if you're taking a sample of 10, okay, that means you probably definitely have a population of greater than 100. Otherwise, you would just calculate the average of the population. So this one's going to be okay. Now, this requires a little bit of assumption, maybe some prior knowledge about how many statistics exams would need to be graded, and so how many teachers you would need. So I would understand if maybe if you said no at this point, but this assumption is definitely met. Okay, and now nearly normal. Now there's two ways that we can check nearly normal. We can do it with a histogram, okay, or we can check it with the mean being nearly equal to the median, okay? And so now for this, I actually need my calculator. I'm going to bring up my calculator, right? And now I hit the stat button and I enter in my list. And in my first list, I'm going to have 265, right? And then 298, 3 240. Okay, 219. 199. 398. 359. 309. Guessing as you get further and further to the east, and 105. Further away from Lincoln, right, the prices are going to go up. Certain cities are going to be more expensive. So you can see we have 10 flights. Okay, and so what I want to do is turn on my stat plot. Okay, I want to turn it on, enter. I want to make sure that it's a histogram. Enter. I just put my stuff in L1, so my frequency is good. And so now I'm going to zoom 9 for zoom stat. And man, could that be any more nearly normal? Okay, so that means that as I go, where's my, all right, so that for east, the histogram looks nearly normal, and that makes me very happy. Now you have to do it for each one, so now I need to do it for the west too, and see what happens there. All right, so I'm going to do the same thing. I'm going to go back to stat, hit edit. I'm just going to go over to L2, because I'm guessing most of you probably did this all at the same time. 257, 320, 295, 288, 366, 275, 430, 397, right, I'm a little dyslexic, so 253, and 366, right? And so now, again, I have all 10 of my data points in there. I'm going to go to stat plot, right? I'm actually going to go ahead and turn off plot 1, okay? And I'm going to go ahead and go to plot 2 and turn it on and make it a histogram, right? And now, oh crap, so my frequency list here should be L2, right? So there's my 2, so there's the L2. And so now that I have that put in, I'm going to zoom. Oh, second, wait. I don't like that function menu. I don't know what that wizard thing is. Zoom, 9. Whoa, whoa. This looks really skewed, okay? Now, it could just be the bin size, right? Could just be the bin size is weird. So I'm just going to go to stat, calculate my one variable statistics. I'm going to put L2 in because I'm looking for that. And I'm going to go ahead and hit calculate. And okay, so my mean score is 324. And my median score is 307. So, you know, basically $310 and $325, and that's kind of far apart. And so I'm going to consider this assumption not to be met. It's 10. Whoa, 10 is way less than 15, which would allow for a little bit of skew, and so we cannot proceed here. Cannot proceed. All right, and so we're going to do 28 next, and that makes everybody happy.